Okay, on this problem, what we want to do is we want to evaluate an integral by using the antiderivatives, the antiderivatives. And this is the nuts and bolts of definite integrals and using what we've learned about derivatives to solve them out. So try using this formula right here. The integral from a to x of f of t dt is equal to f of x minus f of a. In other words, that antiderivative function evaluated at x minus the antiderivative function evaluated at a. So let's just ask ourselves real quick, what is the derivative? The derivative of what? Is equal to the sine of x. And this guy right here, this derivative is what we're really interested in, okay? And so we're going to figure out, no matter how you do it, just think about the derivative of what. And so you should arrive at the negative cosine of x. And so then what we want to do is we're going to use some like fancy stuff here. We're going to say we're going to evaluate this from 0 to pi. Well, what does that mean? That means we're going to follow this step right here. F of x for this problem, f of x is negative cosine x. So what are we going to do? We're going to stick in our upper limit, pi, and we're going to stick in our lower limit, 0. So what we're going to end up with is negative cosine of the upper limit, pi, minus negative cosine, the lower limit, of 0. So the cosine of pi is negative 1, so minus negative 1, minus, and then the cosine of 0 is 1, so minus 1. And I end up here with 1 plus 1 or 2. And that is how you evaluate a definite integral using antiderivatives. The derivative of what gives us this thing in here? That's the question that we're asking. And then we're going to use our upper limit and our lower limit to complete that process. It looks kind of weird and strange. But once you've done it a few times, what you're going to realize is you're taking the stop part of our derivative, the stop part of our function, not derivative, the stop part minus the start part. And you know what? You've been doing that all year long.